The first sound was not the rifle shot but the metal ping, a small, bright noise that echoed across the volcanic rock of Iwo Jima's northern ridges on a February morning in 1945, when the air tasted of sulfur and the sky hung low with ash. An 8-round en-bloc clip tumbling onto black sand, spinning once, then still. The Japanese soldier wedged between two lava fissures had heard that sound 3 times in the past hour, each time followed by the dull concussion of boots on stone, American voices calling grid coordinates. The methodical clearing of tunnels he'd been told would be impregnable. He did not understand how the Americans reloaded so fast. He did not understand why their riflemen fired twice as many rounds in the time it took him to work his bolt once, twice, 3 times. The propaganda leaflets scattered across Saipan 6 months earlier had promised that American infantry were soft, undisciplined, dependent on machines they could not repair. But here, in the smoke and the terrible light of flamethrowers igniting pockets of methane trapped in the volcanic substrate, the propaganda was dying alongside the men who had believed it. The contradiction would take months to fully unravel in the minds of those who survived. But on that ridge, in that moment, the truth was immediate and mechanical. The M1 Garand semi-automatic rifle had rewritten the grammar of infantry combat, and the Arisaka Type 38 bolt action, reliable, accurate, respected by those who carried it, was a language from an earlier war. 7,000 miles east, in a brick arsenal outside Springfield, Massachusetts, machinists in canvas aprons worked third shift under incandescent bulbs that buzzed like horseflies. The smell was cosmoline and hot steel, the floor slick with cutting oil that pooled in the seams of the concrete. Each Garand receiver passed through 47 distinct machining operations before it mated with the walnut stock, the gas cylinder, the operating rod forged in Pennsylvania and tempered in Ohio. The rifles came off the line at a rate that would have seemed mythological to an armorer in any previous century. One every 6 minutes, 24 hours a day, 6 days a week, stacked in wooden crates stenciled with codes that routed them to depots in New Jersey, Georgia, California, then onto Liberty ships that crossed the Pacific under escort, zigzagging to avoid submarines that were themselves running out of fuel and hope. Productivity was not an accident. It was the offspring of rural electrification, standardized public schooling, a culture that had spent 2 decades making automobiles in sufficient volume that young men arriving at training camps already understood torque, tolerance, the idea that parts should be interchangeable. The Garand was not merely a weapon. It was a product of infrastructure, power grids, rail networks, technical high schools, a patent system that encouraged refinement, a procurement bureaucracy that had learned, slowly and painfully, to value engineering over tradition. When General George S. Patton called it the greatest battle implement ever devised, he was praising not just the rifle but the entire system that had made such a rifle possible in such quantities. The woman who would later write the field manual's appendix on maintenance under tropical conditions was not supposed to be in the Pacific Theater at all. Lieutenant Marjorie Henshaw, call sign Hickory 6, had trained as a logistics officer at Fort Lee, Virginia, where she'd spent 8 months routing supply convoys, calculating fuel consumption, and absorbing the peculiar physics of military bureaucracy. Her specialty was propeller testing before they transferred her into ordnance coordination, evaluating how equipment performed not in the controlled environment of a proving ground, but in the chaos of coral atolls, jungle humidity, and the hands of 18-year-old riflemen who had never cleaned a firearm before boot camp. She arrived at Guadalcanal in August 1943 with a clipboard, a sidearm she qualified expert with but hoped never to fire in anger, and a working theory that the most important battles of the war would be fought not by generals, but by the mechanics, armorers, and supply sergeants whose names would never appear in dispatches. Her first assignment was to investigate why Garands were jamming in the Solomon Islands at rates 30% higher than in North Africa. The answer, she discovered, was sand of a particular fineness combined with the salt air that corroded gas ports faster than anyone had anticipated. She wrote a 2-page memo recommending a modified cleaning schedule and a redesigned gas cylinder lock screw. The memo was filed, forgotten, then rediscovered 3 months later when the same jamming issue appeared on Tarawa. By then, Henshaw was already in the Marianas, elbow-deep in the next problem. The Arisaka rifle facing the Garand across the ridges and beaches of the Central Pacific was not a bad weapon. That fact is important to state plainly, because the temptation in retrospect is to assume that Japanese defeat was inevitable, that their equipment was universally inferior, that the outcome was written in the stars before the first shot was fired. The Type 38, introduced in 1905 and chambered in 5 times 50 mm, was a refined evolution of Mauser design principles: strong, accurate at range, tolerant of dirt and moisture. Japanese soldiers trained with it until they could work the bolt in their sleep, a smooth two-motion cycle that became muscle memory, a meditation. The rifle had fought in Manchuria, China, Siberia, and across the Pacific Islands with a service record measured in decades. Its weakness was not quality but design philosophy. It was a bolt-action rifle optimized for an era when infantry combat was expected to occur at 300 to 500 meters, when marksmanship was the supreme virtue, when fire superiority meant disciplined volley fire from entrenched positions. The Garand, by contrast, was built for a different kind of war, one where infantry squads maneuvered rapidly, where suppressive fire mattered as much as aimed shots, where the ability to put rounds downrange quickly enough to keep an enemy's head down while your squad advanced was worth more than perfect accuracy at 400 yards. The Americans had not simply built a better rifle. They had built a rifle for a different tactical doctrine, one that assumed radios, air support, artillery coordination, and the kind of combined arms integration that required every piece of the machine to function at high tempo. The first time Japanese intelligence officers examined a captured M1 Garand was in the Philippines in late 1942, after a skirmish near a coastal village whose name does not matter anymore. The rifle arrived at a field laboratory in Manila packed in sawdust, its serial number recorded, its condition noted as excellent despite having been submerged in a tidal creek for several hours. The engineers who disassembled it were meticulous, photographing each component, measuring tolerances, testing the gas system by firing rounds through it while recording pressure curves. Their report, which survives in fragments in archives that were not burned during the retreat, was technical and precise. The Garand's operating system, they noted, was ingenious. Exhaust gases from the fired cartridge diverted through a port in the barrel to drive a piston that cycled the action, ejected the spent casing, chambered a new round, cocked the hammer, all in a fraction of a second. The system was self-loading, meaning the shooter never had to break his sight picture, never had to take his hand off the trigger, never had to interrupt the rhythm of fire to manually work a bolt. The report estimated that a trained rifleman could deliver aimed fire at 2 to 3 times the rate of a bolt-action equivalent. It recommended immediate development of a Japanese semi-automatic rifle. That recommendation went nowhere. Japan's industrial base in 1942 was already stretched thin, its machine tool inventory a fraction of America's, its steel production bottlenecked by shipping losses, its engineering talent spread across aircraft, naval, and artillery projects. Retooling to produce a new rifle would have required shutting down existing production, retraining armorers, redesigning supply chains. The decision was made to continue with the Arisaka. It was not an irrational decision given the constraints, but it was a decision that would cost lives in increments too small to measure individually but devastating in aggregate. Henshaw's second memo, written in a tent on Saipan under the light of a kerosene lamp, while the sound of distant artillery rolled across the hills like summer thunder, addressed the psychological dimension that no one wanted to talk about. Observed behavior, she wrote, indicates enemy combatants are increasingly reluctant to engage at close range. Prisoners interviewed cite superiority of American rate of fire as primary factor in decision to withdraw or surrender. She did not editorialize. She did not need to. The numbers were stark enough. In the battle for Saipan, American infantry squads engaged Japanese positions at ranges that would have been suicidal in a previous war, 50 meters, sometimes closer, because they could deliver overwhelming fire superiority even while advancing. A single 8-man squad equipped with Garands could put out as many rounds in 30 seconds as a Japanese platoon of comparable size, and they could do it while moving, while taking cover, while maintaining suppression on multiple targets simultaneously. The Japanese response, increasingly, was to retreat into prepared defenses, to rely on night attacks and ambushes where American firepower advantage was reduced, to fight from caves and bunkers, where the rifle's range and rate of fire mattered less than grenades and flamethrowers. This was not cowardice. It was adaptation under impossible circumstances, the kind of tactical evolution that happens when soldiers realize the tools they have been given are not adequate for the war they are fighting. The factories that produced the Garand were themselves a kind of miracle, though that word risks sentimentality where precision is needed. Springfield Armory and Winchester Repeating Arms split production, with smaller contracts going to International Harvester and Harrington and Richardson. The supply chain was baroque. Receivers from one state, barrels from another, gas cylinders from a third, each component meeting tolerances measured in thousandths of an inch, each requiring specialized machine tools that were themselves products of decades of incremental refinement. The walnut stocks came from groves in Missouri and Pennsylvania, kiln-dried, shaped on powered lathes, finished with linseed oil. The ammunition, the .3006 Springfield cartridge that the Garand was built around, came from Lake City Army Ammunition Plant outside Kansas City, where women in hairnets worked production lines that churned out millions of rounds per month, the brass casings stamped and drawn and primed, and loaded in a sequence so efficient that the cost per round dropped every quarter. The logistical choreography required to get a rifle from a factory in Massachusetts to a foxhole on Peleliu involved ships, trucks, trains, depots, armorers, supply officers, and a bureaucracy that had learned, through painful trial in North Africa and Italy, that ammunition and replacement parts had to flow forward as reliably as orders flowed down from command. The Japanese had no equivalent system. Their logistics were heroic, improvisational, and inadequate. Ships sunk before they could deliver cargo, factories bombed, supply lines stretched across thousands of miles of ocean they no longer controlled. Radio intercepts from early 1945, translated by Nisei linguists working in Quonset huts on Oahu, revealed the depth of Japanese awareness. Enemy infantry doctrine relies on rapid fire to suppress while maneuvering, one field report noted. Our soldiers report inability to return effective fire due to volume of incoming rounds. Another, more desperate, request immediate supply of automatic weapons, current armament insufficient for close engagement. The requests were rarely fulfilled. Japan had semi-automatic and automatic rifles in development, the Type 4, the Type 5, but production numbers were trivial, dozens or hundreds where thousands were needed. The factories that might have produced them were being bombed by B-29s, their machine tools destroyed, their skilled workers conscripted into other projects or killed in air raids. By the time the first Type 4 rifles reached combat units in Manchuria in 1945, the war was effectively over. The Arisaka remained the standard, a symbol of a nation that had entered the war with tactics and equipment from one era and was being destroyed by an enemy fighting with tools from the next. Henshaw's diary, fragments of which she shared in an oral history recorded in 1982, captured moments that official reports could not. March 3, 1944. Watched a rifle platoon train on the new ranges. They fire the Garand the way a carpenter swings a hammer, unconscious competence. The weapon is so reliable they barely think about it. That reliability is a form of power we don't talk about enough. A soldier who trusts his rifle will take risks a soldier with a temperamental weapon will not. She was writing about confidence, the intangible variable that does not appear in after-action reports but shapes every firefight. A Marine on Iwo Jima with a Garand knew that if he pulled the trigger, the rifle would fire, eject, reload, and be ready to fire again in a fraction of a second. He knew that if sand got into the action, he could field strip it in under a minute and have it operational again. He knew that the logistics train behind him would deliver more ammunition, more replacement parts, more rifles if his was damaged beyond repair. That knowledge, that systemic confidence, allowed for a kind of aggression that the Japanese could not match. It was not that Japanese soldiers lacked courage. It was that their courage was being spent against a system that could absorb losses and regenerate faster than they could inflict damage. The mechanics of the Garand's gas operation are worth understanding in plain terms, because the engineering is where the advantage lived. When a round fired, a small amount of propellant gas bled off through a port drilled into the barrel about midway down its length. That gas entered a cylinder surrounding the barrel and pushed against a piston connected to the operating rod. The rod, driven backward by gas pressure, rotated the bolt to unlock it from the receiver, extracted the spent casing, cocked the hammer, and compressed a spring. The spring then drove the rod forward, stripping a new round from the end-block clip in the internal magazine, chambering it, and rotating the bolt to lock it. The entire cycle took roughly 1/10 of a second. The system was self-regulating. Gas pressure was consistent enough that the timing worked across a wide range of temperatures and ammunition loads. The only manual intervention required from the shooter was pulling the trigger and every 8 rounds, inserting a new clip. The clip itself was a piece of brilliance. A thin stamped metal frame that held 8 rounds in a staggered column, designed to be inserted into the rifle from the top, pushed down until it locked, at which point the bolt would slam forward and chamber the first round. When the last round fired, the clip ejected automatically with that distinctive ping, signaling to the shooter, and unfortunately to anyone nearby, that the rifle was empty. Veterans learned to carry spare clips in ways that allowed for quick reloads, a 2-second operation under ideal conditions, longer under fire but still faster than loading individual rounds into a bolt-action magazine. The Arisaka, by contrast, required the shooter to manually operate the bolt after each shot, lift the bolt handle, pull it back to extract the spent casing and cock the hammer, push it forward to chamber a new round from the fixed internal magazine, rotate it down to lock. A trained soldier could do this quickly, but not as quickly as pulling a trigger. The magazine held 5 rounds, loaded from the top via stripper clips. Reloading required the soldier to disengage from his sight picture, open the bolt, position the stripper clip, push the rounds down with his thumb, remove the clip, close the bolt. In the time it took to do this, a Garand shooter could fire, reload, and fire again. The disparity was not theoretical. In firefight after firefight across the Pacific, American squads documented kill ratios that would have been unthinkable in a previous conflict. Not because American soldiers were better shots, though training helped, but because they could deliver more rounds per minute, and volume of fire is, in infantry combat, a form of pressure that breaks formations, suppresses movement, and creates windows for maneuver. The Japanese adapted by fighting from positions where they could not be flanked, where fire superiority mattered less than fortification and the willingness to die in place. That adaptation was effective in the short term. It was also a concession of the infantry fight, a recognition that meeting American rifle squads on equal terms was no longer possible. The port of San Francisco in late 1944 was a machine operating at the edge of chaos, piers crowded with Liberty ships, cranes swinging cargo nets loaded with crates stenciled in white paint, forklifts racing back and forth, longshoremen working 12-hour shifts, the smell of diesel and creosote, and the cold salt wind off the bay. Henshaw spent a week there on temporary assignment, coordinating the shipment of armorer's tools, replacement gas cylinders, and a new batch of technical manuals to depots in the Marianas and the Philippines. She watched a single crane load 60 tons of materiel onto a ship in 8 hours, a task that would have taken 3 days with manual labor. She watched forklifts move pallets that would have required a dozen men. The mechanization was not dramatic. It was prosaic, the kind of incremental advantage that compounds across millions of transactions until the aggregate difference becomes overwhelming. Japan's ports, by contrast, were still largely manual, still reliant on human muscle and rope and wooden cranes that had changed little in decades. The throughput difference was measurable. An American port could load or unload a ship 3 to 5 times faster than a Japanese equivalent. That difference, multiplied across hundreds of ships, thousands of voyages, millions of tons of cargo, was the foundation of everything else. The rifles, the ammunition, the replacement parts, the food, the medicine, the fuel. Logistics, Henshaw noted in a letter to a former professor at Smith College, was the unglamorous substrate of victory. We do not win because we are braver. We win because we can deliver more of everything faster to more places and sustain it longer. The training of an American rifleman in 1944 was an 8-week process that assumed the recruit had at least a high school education, basic literacy, and some familiarity with mechanical systems. The assumption held more often than not. American public education, for all its flaws, had produced a generation of young men who understood gears, levers, cause, and effect. The idea that a machine could be disassembled, understood, repaired. The Garand was taught in stages, nomenclature first, then disassembly and reassembly blindfolded, then dry firing to build trigger discipline, then live fire at progressively longer ranges, then malfunction drills, then fire and movement. By the end of training, a rifleman could field strip his weapon in under 60 seconds, diagnose common malfunctions by sound and feel, and put rounds on target at 300 yards. The training was not gentle, but it was systematic, built on a pedagogy that understood learning curves and repetition and muscle memory. Japanese training, by contrast, emphasized spiritual discipline and marksmanship, but often lacked the systematic approach to mechanical familiarity. The Arisaka was simpler, which meant it required less training, but simplicity is not always an advantage. A bolt-action rifle has fewer parts to break, but also fewer options when something does break. The Garand, with its gas system and operating rod and ejector spring, was more complex but also more repairable in the field. An armorer with basic tools could replace a worn gas cylinder or a bent operating rod in minutes. The Arisaka, if its bolt lugs were damaged or its firing pin broke, often became deadweight. By the time the Marines landed on Iwo Jima in February 1945, the material advantage was so overwhelming that Japanese commanders no longer planned for victory in the conventional sense. The plan was attrition, to kill as many Americans as possible, to drag the invasion out, to make every yard of volcanic ash cost enough blood that the American public would lose the will to continue. The strategy was not irrational given the tools at hand, but it was a strategy of desperation, and desperation has its own mathematics. The caves and bunkers on Iwo Jima were marvels of engineering, interconnected tunnels that allowed defenders to move unseen, to concentrate fire, to retreat and reappear. But the Garand's advantage held even in that environment. American infantry squads entering tunnels could deliver suppressive fire without pause, could keep defenders pinned while flamethrowers moved forward, could sustain fire superiority in spaces measured in meters. The Arisaka's bolt-action mechanism, so effective at long range in open terrain, was a liability in close combat where speed mattered more than precision. Japanese soldiers learned to ambush from point-blank range, to use grenades and bayonets and suicide charges, tactics born from the recognition that a rifle duel with American infantry was a losing proposition. The battles were brutal and the casualties staggering on both sides, but the trajectory was never in doubt. The side with more firepower, more ammunition, more replacements, and more logistical depth would win. The only question was how long it would take. Henshaw's role on Iwo Jima was not to fight but to observe and document. She moved between aid stations and supply depots, interviewed riflemen about weapon performance, collected damaged Garands for evaluation, wrote recommendations that would be incorporated into maintenance manuals and training updates. She was not supposed to be near the front lines, but the front lines on Iwo Jima were everywhere. There was no safe rear area, no space beyond the range of mortars and artillery, and the occasional sniper with a scope-equipped Arisaka firing from a cave entrance 1,000 yards away. She wrote in her diary about the sound of the island, the constant crackle of rifle fire, the deeper thump of grenades, the scream of aircraft overhead, the weird silence that would descend at random moments when everyone on both sides was reloading or repositioning or just too exhausted to continue. March 1, 1945. Saw a rifle company come off the line today. 19 men out of an original 41. Their Garands were filthy, caked with ash and blood, but still functional. The armorer cleaned them in an hour. The men were not so easily repaired. She did not romanticize war in her writing, did not pretend that superior equipment made death less random or loss less absolute. But she understood that the Garand had kept some men alive who would have died with a lesser weapon, had given them a fighting chance in circumstances where chance was the only thing anyone had. The propaganda war by 1945 had fully inverted. Where Japanese leaflets early in the war had mocked American softness, American dependence on luxury, American inability to endure hardship, the late-war leaflets found on Okinawa and in the Philippines told a different story. They emphasized the futility of resistance, the overwhelming material superiority of the Americans, the certainty of defeat. Some leaflets included technical details, illustrations of the Garand, descriptions of American artillery and air support, statistics on production capacity. The intent was to break morale by demonstrating the hopelessness of the fight, but the effect was sometimes the opposite. Soldiers who had been told they were fighting soft, weak enemies now realized they were facing an industrial colossus, and that realization brought a kind of bleak pride. If we must lose, at least we are losing to a worthy opponent. The psychology is complex and does not lend itself to easy summary, but the documents are clear. By mid-1945, Japanese soldiers in the field understood that the rifle in their hands was not the equal of the rifle in their enemy's hands, and that knowledge shaped every decision they made about when to fight, when to retreat, when to surrender, and when to die. The numbers, in the end, tell the story more clearly than any narrative can. The United States produced approximately 4 million M1 Garand rifles during the war. Japan produced approximately 3.5 million Arisaka rifles of various types, plus smaller numbers of other weapons. The production figures are roughly comparable, which might suggest parity, but the comparison is misleading. The Garand represented a qualitative leap, a weapon that allowed a single soldier to do the work of 2 or 3 bolt-action riflemen. The force multiplier was not linear. It was exponential when combined with American advantages in artillery, air support, logistics, and industrial depth. A Japanese infantry battalion equipped with Arisakas faced an American infantry battalion equipped with Garands and immediately operated at a disadvantage that no amount of training or courage could overcome. The only way to neutralize the advantage was to avoid the kind of combat where firepower mattered, which is precisely what Japanese tactics evolved to do. But you cannot win a war by avoiding combat, and you cannot avoid combat indefinitely when your territory is being invaded. The end game was written in the specifications, in the rate of fire and the reload time and the logistical throughput and the training pipelines and the industrial base. The Garand did not win the war alone, no weapon does, but it was a critical node in a network of advantages that, when combined, were insurmountable. Henshaw returned to the United States in September 1945, 3 weeks after the surrender was signed on the deck of the USS Missouri. She carried with her a duffel bag full of notes, diagrams, captured Japanese training manuals, and a single battered Garand that had been carried by a Marine through Guadalcanal, Tarawa, Saipan, and Iwo Jima before its stock finally cracked beyond repair. The rifle is now in a collection at the National Museum of American History, its serial number logged, its provenance documented. Henshaw spent the next 2 years compiling her observations into a technical report that became required reading for logistics officers at Fort Lee. She never claimed to have won the war or changed its course. She understood her role as one small node in a vast system, a system that worked because millions of people performed small tasks competently, because infrastructure existed to support those tasks, because a nation had decided that winning required not just brave soldiers but functioning factories and power grids and schools and rail lines, and all the mundane architecture of industrial modernity. The rifle, she wrote in the report's conclusion, was a symptom, not a cause. It was the visible edge of an invisible advantage, the advantage of a society that had invested in its people, its infrastructure, and its capacity for organized complexity. The legacy of the M1 Garand extends beyond the war it was designed to fight. It remained in U.S. service through Korea, was used by allied nations for decades, influenced the design of battle rifles and automatic weapons that followed. But the deeper legacy is conceptual. The Garand demonstrated that semi-automatic fire was not a luxury or a niche application, but the new baseline for infantry combat, that the soldier of the future would be a technician as much as a warrior, that firepower and reliability and ease of maintenance mattered as much as accuracy or range. The bolt-action rifle, which had dominated infantry combat since the 1880s, was suddenly obsolete, a relic of a slower kind of war. The transition was not immediate. Many nations continued to issue bolt-actions into the 1950s and beyond, but the direction was set. The future belonged to weapons that could fire as fast as a soldier could pull the trigger, that did not require the shooter to break his sight picture or his rhythm, that were designed for sustained rapid fire rather than deliberate marksmanship. The Garand was the first mass-produced realization of that future, and the wars it fought proved the concept beyond dispute. The Japanese soldiers who survived the war and returned home carried with them memories of many things: the hunger, the heat, the disease, the casual cruelty of industrialized violence. But many also carried memories of that specific sound, the rapid crack-crack-crack of Garand fire, the relentless pressure of it, the way it never seemed to stop long enough for a counterattack. Some wrote about it in memoirs published decades later, describing the psychological weight of facing an enemy who could shoot twice as fast, who never seemed to run out of ammunition, who advanced with a confidence born from knowing their weapons would not fail them. There is no glory in these accounts, no romanticism. Just the plain recognition that they had fought with the tools of one era against an enemy armed for the next, and that the gap between the two was measured in blood and ash and small metal pings echoing across volcanic rock. The sky over Iwo Jima on March 26, 1945, was the same sulfur gray it had been a month earlier, the ash still drifting on the wind, the smell of the island unchanged. But the rifle fire had stopped. The caves were silent. The last organized resistance had ended 3 days before, though isolated holdouts would remain for weeks, months, some refusing to believe the war was over even when the evidence surrounded them. Henshaw stood near the airfield, watching bulldozers level ground for a new runway, watching Seabees unload construction equipment from landing craft, watching the machinery of occupation replace the machinery of conquest. She thought about the rifle she had carried for 2 years, the one that had never jammed, never failed, never given her reason to doubt it. She thought about the soldiers who had trusted their lives to that weapon and the ones who had not survived despite it. She thought about the engineers in Springfield and the machinists in Winchester, and the women at Lake City, and the whole vast web of people who had built the tools that ended here, on this miserable island, in this victory that tasted of ash and iron. And she thought about the future, about the wars that would come after this one, about the weapons that would replace the Garand just as the Garand had replaced the Springfield before it, and the Springfield had replaced the Crag, and the Crag had replaced the trapdoor, each generation building on the last, each leap forward making the previous generation obsolete. War was not glorious. War was engineering, and the side that engineered better, faster, at greater scale would win. That was the lesson. That was the legacy. That was the cold truth written in steel and blood, and the small bright sound of a clip ejecting onto volcanic sand.